Hey everybody, this is going to be your finals review video for accelerated algebra. I don't know how long it'll go to take. You do, because you get to see the bottom of the YouTube video. But I'm just going to go through all the questions here. I have a calculator here. Hopefully I don't make any mistakes, but I am doing like 6 tests in a row, so likely I'm going to make a mistake here and there. If I do make a mistake, just let me know in class. Otherwise, let me get through it and try to explain a little bit of everything from all the tests. Because it's a video, you can go back if you think I'm going too fast, or if you're going too slow, just hit it at 1.5 speed. Alright, let's start this up. Square root of 50, we want to break down. Because this is square root, it's a divisible 2, so I need a 2 of a kind. 25 and 2, 5 and 5. Because I have a pair of 5s, that goes to the outside, so it's 5 root 2. Over here, same thing. The easiest way to do it is to figure out which ones are squares ahead of time. So I can figure out this is 16 and 3. Because I know this is 16, I know this is going to be 4 and 4, which I know this is going to be 2, 2, 2, 2. So if you notice that it is 16, you could just say, oh, it's the square root of 16 times the square root of 3. I know the square root of 16 is 4. So 4. Now, x cubed, the problem with x cubed is 3x's. So because there's 3x's and it's a square root, I just need 2 of them. So one's going to be on the outside and one's going to be left on the inside. For y4, that's 4 y's. Because there's 4 y's, one pair here, one pair here. There's none left over inside. So 4xy squared, square root of 3x is the leftover 3 here and the leftover x here. This one, the square root of 9 is 3. The square root of x6 is going to be x to the third. You can either remember the square root of x to the 6 is x to the third because you know it's half, or if you remember, since we're square rooting, it's the same as doing 6 over 3 or 6 over 2, which is a half. So this is x3 x to the third times 7 x to the fifth. When you multiply normal numbers, that's normal, so 21. When you multiply x to the fifth and x to the third, that's x to the eighth. You add exponents. This is a cube root. Because it's a cube root, I need a 3 of a kind. It's 120, so I see 12 and 10, 4 and 3, 2 and 2, and then 10 over here is 2 and 5. Because it's to cube root, I need a 3 of a kind. So I'm going to take all those 3. That's going to get to leave the root. So 2. And then whoever I leave behind, 3 and 5. 3 times 5, 15. When multiplying roots, you multiply the outsides. So that's 12. And you multiply the insides, 150. Now I need to break down 150, but I know for a fact 150 is going to be 10 times 5. So I can just start it off by calling it 10 and 15. I should say 10 and 15. Again, break it all the way down. I have a pair of 5s here. Because I have a pair of 5s here, that's going to go on the outside and multiply with the 12. So it's going to be 60. Left over, I put 2 and the 3. So 60 root 6. Alright, this is a fraction here. So the first thing you could do is square root. Or I'm sorry, the first thing I'm going to do is just simplify the fraction. So simplifying the fraction, it becomes 16 over 9. And since it's a fraction, what you can do is square root both of them separately. So square root of 16 over square root of 9. And hopefully by the time you're here, you know the square root of 16 is 4, and the square root of 9 is 3. When you add or subtract roots, they have to be the same root. So I have to break this down and simplify. To save time, I broke it down a bunch of them. So I'm just going to give the result. This is going to be 2 root 2. This is going to be 5 and 10, so 5, 5, 2, 5 root 2. And this is going to be 3 root 2. When you add, you only add the fronts, or subtract, you only add the fronts. So 2 plus 5 is 7, minus 3 is 4. So 4 root 2. Over here, we have 10 over root 5. Is more of a grammar thing, is the best way I can describe it, where we don't like square roots on the bottom. Because we don't like the square root on the bottom, we're going to multiply the top and the bottom by root 5. That's going to be 10 root 5 over 5. 10 and 5 could simplify, so 2 root 5. Next one, we have a square root on the bottom. But in this case, it's 2 plus root 6. If I do just root 6, it would distribute to here, and it'll be 2 root 6 plus 6. So it doesn't solve my problem, because I still have a square root on the bottom. So when I have a plus or a minus, I need the conjugate to solve it. So I'm going to need 2 minus root 6, 2 minus root 6. On top, it's going to be 6 minus 3 root 6. I just distribute this 3 to here and here. On the bottom, it's going to be a difference of squares when you FOIL. So you're going to get 2 times 2, which is 4. 2 times negative root 6 is negative 2 root 6. Root 6 times 2 is positive 2 root 6. And then root 6 times negative root 6 is root negative 36, or just 6. Because we did it with the conjugate, where it's plus minus, always the middle cancels out. So for future reference, you don't actually have to do the middle. So all I do is 4 minus 6, which is negative 2. So 6 minus 3 root 6 over negative 2. If you use AI for this, it might give you the answer negative 3 root 6 plus or minus 6 over 2. They just put the negative in front and affect the top. These are both the same thing. I probably, if it was a multiple choice, I actually might have to do it this way. Because for a multiple choice, this will be more proper. Alright, this one. It's root 10 plus root 6 squared. Please do not be a fool and just distribute the square root. That's going to be definitely one of the fake answers in the multiple choice. Instead, what you're going to have to do is rewrite it as 2 and then FOIL. So root 10 plus root 6 times root 10 plus root 6. We're going to FOIL out. That's going to be just 10 plus root 60 plus root 60 plus 6. Real numbers go together, 16. Roots go together, 2 root 60. But 2 root 60 can be broken down. 6, 10, 3, 2, 2, 5, pair of 2s, so that goes on the outside. So I can rewrite it as 16 plus 4 root 15. All right, when you have negatives inside your square roots, you deal with it by using I. So I still break this down normally. So 18 is 9 and 2, 3 and 3. So when I rewrite this, it's going to be 3I root 2. Remember that I is the square root of negative 1. Because that's true, you also have to remember that I squared is negative 1. That's going to be relevant for the next question. So there's some relevant facts there. Over here, I'm allowed to distribute the 2 because there's no plus or minus on the inside. Compared to number 10, which had a plus sign inside, so I had to rewrite it. This one, there's no plus or minus, so I can just distribute. So in this case, it's going to be 3 squared, 9, I squared, negative, root 2 squared, 2. So negative 18. For number 13, you're subtracting here. So 5 minus 2, 3. And then over here, it's 3i minus negative 6i. So you add that, 9i. You're adding negative 10 plus 3, negative 7. 12i plus 5i, 17i. Over here, you're foiling. 2 times 2, or 2 times 4, 8. 2 times 5i, 10i. 3i times 4i, 12i. And 3i times 15i is 15i squared. But remember, I squared is negative 1, so this is the same thing as saying negative 15. Combine real numbers, 8 and negative 15, negative 7. 10i plus 12i, 22i. Same thing here. You have to FOIL it out by rewriting it as 3 minus 5i. 3 minus 5i. To FOIL this, you end up getting 9 minus 15i minus 15i plus 25i squared. Remember, 25i squared becomes a negative 25. So this is all becomes negative 16 minus 30i. This one, you can either break down first and then multiply, or you can break it all down and then work together between the two, simply because it's multiplication. So for this case, 35, I know is going to be, I'll put an I in front, but 35 is going to be 5 and 7. And I know 14 is 7 and 2. Because I'm multiplying, these will mix eventually, so I could use one from one side and one from the other side, and just move it to the front. This also has an I. So this is going to be I squared, or negative 7, square root, my leftovers, which is 5 and 2, 10. You can multiply it first. Remember though, the i's have to be taken out before you multiply. It is actually negative 7 root 10, not positive 7 root 10. It's a weird Sage thing. You take out the i's first. Same thing here, take out the i's, they have to be similar. In this case, this is going to be 4i plus 7i, which makes it 11i. Over here, it's going to be negative 45 plus negative 80. So break this down. I'm just going to go a little quicker just so I save time. 3i root 5 plus 16 times 5, so 4i root 5. Because these are like terms, I can actually combine them. So 7i root 5. Notice how these stay the same. These are what takes it as the like term. Next one, 4 over root 3i. Remember, it's a grammar rule that we don't like square roots, and square roots on the bottom of fractions. And I is technically square root of negative 1. So the easiest thing is to multiply I over I. Can you multiply 3i over 3i? You could, but you'll have to simplify more. So just take the i's. That's the actual problem. So it's 4i over negative 3. How it would be written on a multiple choice is negative 4i over 3. Over here, problem, we have I with a minus sign, so I'm going to need its conjugate. So 2 plus 7i, 2 plus 7i. The bottom I'm going to do quickly, which is going to be 4 minus 49, after I clean up the i's. Actually, 4 plus 49, I should say. On top, I'm going to FOIL. That's going to be 10 plus 35i plus 6i plus 21i squared, which is secretly negative 21. So it's going to be 10 minus 21, negative 11, plus 41i over 53. You should always check if you can simplify something, but in this case I can't simplify. Alright, solve. I got a minus 21. Minus 21. I got x squared equals negative 16. Now I'm going to square root both sides. So x equals plus or minus 4 I. So when you're solving for x, you need a plus or minus, because the question you're technically answering is what could go into x. What could go into x? Well, positive 4i could go into x, or negative 4i could go into x. That's why you have to put a plus or minus when you're solving for x. When you do the square root of a I, like here, you just write negative 7, or let me see. When you just do a normal square root, which I think happened on the first page, you don't need to list that it's both negative or positive. You just give me the positive version. All right, let's keep going. Oh, that's it for the radical test. Let's keep going to the next part. Or that was imaginary. So now we're going to quadratics. So, solve by using complete the square. As a reminder to complete the square, what you want to do is first move all your x's to one side and move all your non-x's to the other side. So I have x squared plus 8x equals positive 20. Now I'm going to put the perfect letter C here. To get the perfect letter C, you do b over 2 squared. In this case, b is the number in front of x, which is 8. So 8 over 2 squared, which is 4 squared, which is 16. Because it's 4 squared, I know this is going to be a 4, and this is going to be a 4. Now, in this situation, oh, sorry, I said 4. This is going to be 16, and this is going to be 16. So now on this left side, I have x squared plus 8x plus 16 equals 20 plus 16, 36. Now here, I could factor normally. So because on this side I could factor normally, what I'm going to do is what multiplies to 16 that adds to 8. I found it earlier, which is the number 4. So I can rewrite this part as x plus 4 times x plus 4, or x plus 4 squared. Because it's squared, now I'm allowed to square root both sides. Get rid of the square here. So now I have x plus 4 equals plus or minus. Remember, when you square root on both sides, that's when you include the plus or minus. 6. And because now you have two different situations with plus or minus, the easiest way to deal with it, because our brain can't really dual process, is just do x plus 4 equals positive 6. X plus 4 equals negative 6. Subtract on both sides. X equals 2. Subtract on both sides. X equals negative 10. Now, rightfully so, somebody might say, Mr. Tobel, in a multiple choice question, how would you force me to do complete the square on a question like this when I could just use normal factoring? I could have solved negative 20. What multiplies to negative 20 but adds to 8? I could have solved that was going to be 10 and negative 2 and then solve it afterwards. You're right in a multiple choice. I can't force you, but I could have it in the open-ended. So that's why you need to know the process. Even though, yes, looking at this question, when you're doing it on the final, you can do it however you want. All right, number 2. First off, I'm looking and I see all these numbers over here are divisible by 3. So the best thing I can do is divide everything by 3. So x squared plus 4x with a little blank equals 15. Now I need the perfect letter C. Perfect letter C. So c equals b over 2 squared, 4 over 2 squared, 2 squared, 4. So this is going to be a 4, this is going to be a 4. This left side I'm going to rewrite as x plus 2 squared. On the right side is just 15 plus 4, which happens to be 19. Time to square root both sides. So I got x plus 2 equals plus or minus the square root of 19. Can't really do more about that because this is a dirty square root. Like, I can't simplify it. So minus 2 minus 2. X equals plus or minus the square root of 19 minus 2. All right. This one, it says solve using the quadratic formula. Just to point out, you could also solve these with quadratic formula. That was totally possible. Now, before you solve the quadratic formula, you got to make sure it equals 0. This one does. Second part, you have to figure out what your a, b, and c. A is always in front of x squared, so a in this case is 1. B is always a number in front of x, in this case b is 6. C is going to be the number by itself, so that's c equals 4. Because of that, what we're going to do is now put it into the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So now I'm just going to plug in all these numbers where they belong. Negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 4 over 2a. 2 times 1. I do the math in the square root first, honestly. So this is 36 minus 16. So negative 6 plus or minus the square root of 20 over 2. Then to clean this up, I got to break down the square root of 20, just like we did in the previous test. Negative 6 plus or minus 2 root 5 over 2. And in this case, all these things are divisible by 2. So I'm allowed to simplify. So the final answer, negative 3 plus or minus the square root of 5. If it was a multiple choice question, this is how the answer would look like. All right, something like this. Again, it has to equal 0. It does not equal 0 yet. So I'm going to plus 6 on both sides. 4x squared plus 11x plus 6 equals 0. Now, my a is 4, my b is 11, my c is 6. I could plug it in. 11, negative 11 plus or minus the square root of 11 squared minus 4 times 4 times 6 all over 2 times 4. Again, I like to deal with the square root first. So 121 minus 24 times 6, no, 16 times 6, or 24 times 4, 96. So that's going to be 25. So negative 11 plus or minus the square root of 25 over 8. But I actually know the square root of 25. That's 5. Because I know the square root of 5, or I know the square root of 25 is 5, now I split it as 2 separate questions because our brain can't dual process. So negative 11 plus 5 over 8, and negative 11 minus 5 over 8. So negative 11 plus 5 is 6, so negative 6 over 8, or simplifies to negative 3 over 4. Negative 11 minus 5 is negative 16 over 8, which is negative 2. So, the nature of roots, if you remember, is the discriminant. The discriminant is b squared minus 4ac. Now, this b squared minus 4ac should feel familiar because that is literally what's inside my square root in the quadratic equation. But how many roots you have is dependent on what's inside your square root. If this is positive, aka bigger than 0, then you know you have 2 real roots. If it's positive, then you have like a positive 5 in this case, which means you could do plus 5 or minus 5. That caused 2 real roots. If b squared minus 4ac is equal to 0, you get 1 real root. Because it's 1 real root, because if you square root 0, when you square root 0, it is just 0. Even if you plus or minus it, you're adding or subtracting 0, so it gives you the same answer. And the last one, b squared minus 4ac is less than 0. In this case, it's negative, and when you square root a negative, it's imaginary. But there's still 2 of them, so it's 2 imaginary roots. Now, I'm going to be fair. I don't remember if I taught it to you as 2 imaginary roots or 0 real roots. Because these 2 things are technically the same. Officially, it's 2 imaginary roots, so we're going to stick with that. But I might have taught it as 0 real roots. In a multiple choice, it would be 2 imaginary roots, okay? Honestly, in this multiple choice question, I already could see option A is going to be 2 real roots. Option B, 1 real root. C, 2 imaginary roots. And option D will be 1 imaginary root. But 1 imaginary root is like impossible. So that's just like, if you click it, then I know you did it wrong. You had no clue what you were doing. Anyway, we have here, I just got to do b squared minus 4ac. So 8 squared minus 4 times 1 times 4. 64 minus 16 equals, I really don't care. Like, I know it's 48, but I don't really care. I'm just looking at this as positive. So 2 real roots. Over here, same thing. Negative 10 squared. Whenever you type into the calculator, actually I should show this right now. Whenever you type into the calculator, if I put negative 10 squared, the problem is it'll give you negative 100. But I'm sure you're smart enough to know negative 10 times negative 10 is actually positive 100. That's why in the calculator, always put your negatives in parentheses when you square, and typically when you do with fractions, because now it comes out correctly as positive 100. Just want to show that now. So negative 10 squared minus 4 times 1 times 25. So this is going to be 100 minus 100 equals 0. That's 1 real. Here, before you could do the discriminant, you have to make sure it equals 0. So 3x squared plus 6x minus 15 equals 0. So now I do 6 squared minus 4 times 3 times negative 15. So that's 36 plus... Well, I know this is going to be plus something, so who cares? Because this is going to be a positive number. So I know this is going to be 2 real roots. Remember, it has to equal 0 before you start. Alright, this one's solved for x. In this case, we have x to the 4 and x squared. So how I taught you how to do this is you're going to use u substitution. Get used to that term when you get to senior year. So u substitution. I'm going to call u the middle term, which in this case is x squared. Which means u squared is the same as saying x squared squared, or x to the 4th. I see an x of 4/4, so I can replace that with u squared. So u squared plus 11. I see x squared. I can say x squared. I can replace that with just u plus 18 equals 0. Now I can factor like normal. 1 multiplies to 18, that adds 11. Not many things, but 9 and 2. So u plus 9 and u plus 2. Now I can split and solve. U equals 9. I'm sorry. U plus 9 equals 0. U plus 2 equals 0. U equals negative 9. U equals negative 2. Now that I got the u by itself, I can replace it back with what I really want, which is x squared. So x squared equals negative 9. X squared equals negative 2. Which means when I square root both sides here, that's going to be plus or minus 3i. And when I square root here, that's going to be plus or minus I root 2. Same thing here. Clarify my u's. I'm going to clarify my u as the middle term. So in this case, it's square root of x, which makes u squared the square root of x squared, or just x. Which means I can rewrite this as 2u plus u minus, I'm sorry, u squared, plus u minus 24. We're going to have to factor it. I don't remember if you remember how to factor when you have a number in front. You multiply 2 and 24. That's going to be negative 48. You have to figure out things that multiply to negative 48. That adds to, in this case, positive 1. Let's see. 8 and 6. Not that. Actually, this one does not have a clean factoring. I wonder if I made that mistake when I gave out the test. This one doesn't have a clean factoring. So let's make it 12. So this is going to be 12, which is going to be negative 24. Oh, wait, that doesn't even solve it anyway. We're going to have to skip this question because it doesn't have a clean factoring. But you would factor it. Let's just pretend it was 8 and 6. It'll be u equals negative 8. U equals negative 6. Replace u on both sides. So square root 8x equals negative 8. So you would square both sides. X equals 64. And square root of x equals negative 6. Square both sides. X equals 36. So in this scenario, I made a question that's not easily factorable. On the test or slash final, they'll be easily factorable. For a u substitution, I would not expect you to have to force yourself to do a complete the square or a quadratic formula. Maybe I was expecting to do that for this version, but won't be on the final. All right, next one. We're on the next test, which was graphing quadratics. All right, a couple of things. So this is the standard form. So the standard form, just a reminder, is ax squared plus bx plus c. So before I do the vertex, I find the axis of symmetry. To find the axis of symmetry, it's negative b over 2a. If you remember, negative b over 2a is just the outside. Where is it? Here. It's just the outside of the square root in the quadratic formula. The inside is the discriminant. The outside will get you the axis of symmetry. So, negative b over 2a. Somebody might be thinking, do I get this as a formula? Definitely not this part. No way. You just need to know that. So, negative b over 2a. So, in this case, negative b over 2a, or 4 over 2, that's going to be negative 4 over 4, which is negative 1. So negative 1 is my axis of symmetry. Automatically, because it's my axis of symmetry, it is also the x of my vertex. Automatically, because it's the axis of symmetry, it's the x of my vertex. So this is negative 1 comma blank. How do I find the blank? Well, to find the blank, I'm going to plug it into my equation up here. So I go 2 times -1 squared plus 4 times -1 plus 2. -1 squared happens first, so that's +1. So 2 minus 4 plus 2 equals 0. So this is 0. So I know my vertex is at -1, 0. So over here. Now, the max or the min. The max or the min is just the y value of the vertex, or if you remember, the k value. I guess I should state this. The vertex, usually we refer it as h comma k, so the max or min is y equals k, because that's literally the highest or lowest it gets to. In this case, because it's going to be facing upwards, it is a min, and then we'll say y equals the y value, so 0. So y equals 0. The x-intercept is where it hits the x-axis. Let's finish graphing. So the x-intercept is when it hits the x-axis. So when to figure out how it hits the x-axis, we make y equals 0. So y equals 2x squared plus 4x plus 2. If you do all the math, you're going to end up getting it is just -1. It is just -1, so -1 comma 0 technically. It happens to be the same in the vertex in this case. The y-intercept, you make x equals 0. So y equals 2 times 0 squared plus 4 times 0 plus 2. Well, this disappears because of 0, and this disappears because of 0. So y equals 2. So it's going to be at 0, comma 2. So my y-intercept, which I'll do in orange here, is 0, comma 2. Now, the easy way to remember this, since I went one right to get to my y-intercept, I should go one left to get the mirror. You always want to mirror if possible. So since it's my vertex, I went one right to get the y-intercept. I'm going to go one left to mirror it. Then I'll connect my dots. Make a U-shape. All right, the domain. The domain is based off the x values. But in this case, this U shape will technically go wider and wider forever, and wider forever. So the domain is all real numbers. So either I'm going to write this symbol. If I can't make the computer write this symbol, it will say all real numbers on your final exam. All real numbers. Your range is going to be your y values. In this case, it cannot go below 0. It can't go below 0. This is the lowest it goes. So my range is y is greater than or equal to 0. So it's always going to be y is greater than or equal to my k value, or y is less than or equal to my k value. If it's facing upwards, it's greater than. If it's facing downwards, it's less than. Number 2, this is written in vertex form. In vertex form, it's written like this: y equals a, x minus h squared plus k. So lucky for me, in vertex form, lo and behold, the vertex is really easy to figure out. So in this case, in the vertex form, h is technically the number here, but because it's minus in this part of the equation, you have to flip it. I'm technically plugging in +3, so it stays -3. If I plug in -3, it would become positive, +3, x plus 3. So the vertex, always flip the h value. So in this case, instead of -3, it's +3. The k value stays the same, -1. The axis symmetry is just the x value of my vertex, or the h value. So x equals 3. Oh, I forgot to graph the axis symmetry. To graph the axis symmetry, that's my fault on this part. To graph the axis symmetry, you just put a dotted line where your vertex is, because it's like a mirror between the two. I'll do it again over here. So right now I know my vertex is 3, -1. 1, 2, 3, -1. So over here, my axis of symmetry, which I'll do in orange, is a line, a dotted line that goes from here to here. All right, is it a max or a min? Because the A value is positive, it goes up like this, which means I have a lowest value possible. So it's a min. The min is just going to be the K value. So it's going to be y is equal to -1. The x-intercepts, to find the x-intercepts, we set y equals 0. Let me do that in green. So we're going to set it to y equals 0. So 0 equals x minus 3 squared minus 1 plus 1 on both sides. Now I have to square root both sides. Remember, when you square root, it's plus or minus. So plus or minus 1 equals x minus 3. I have two versions. Our brains can't dual process. So 1 equals x minus 3, or x equals 4. And -1 equals x minus 3 plus 3 on both sides. That makes it x equals 2. So my x-intercepts are 2, 0 and 4, 0. So I should draw that out. 2, 0, 4, 0. The y-intercept is when you make x equals 0. So I'm going to take it and make x equals 0. So y equals 0 minus 3 squared minus 1. Y equals -3 squared minus 1. 9 minus 1, 8. So it's 0, 8. So I'm going 3 left from the vertex and going up 8. Now, to mirror this, because this is an axis of symmetry, I can see this is 3 away. So I'm going to mirror it by putting another dot 3 away. This will help you make the V shape. Now, I don't think I forced you to give you the mirror, but this is just a way to help you graph it. Now we have our dots. I could just make my U shape. Horrible. My fault on that. The domain. All real numbers. Again, it might be typed out like the words all real numbers if I can't find the symbol in the computer. The range, because it's facing up, is greater than. So y is greater than or equal to my k value, which in this case is -1, or my minimum value technically. Another axis symmetry, or another vertex form. So in this case, A is -1. H is, I guess I'll put it here. H is -2, comma, +4. So 2 left, 4 up. 1, 2, 3, 4. The axis of symmetry is x equals -2, just my h value. Is it a max or a min? In this case, since it's facing downwards, it's a maximum. And in this case, the maximum is the y value, or the k value, I should say. So y equals 4. To find the x-intercepts, you set y equals 0. So I get y equals, or I shouldn't say so y. 0 equals -x plus 4, x plus 2 squared plus 4, minus 4 on both sides, then divided by -1. So I get +4 equals x plus 2 squared. Square root both sides, plus or minus 2 equals x plus 2. We're going to do the math quickly. -2 is going to be x equals 0. -2 is going to be x equals -4. So in this case, your x-intercepts is 0, 0, and -4, 0. Now, I might have pointed this out in the past, but if this is 0, 0, then I know my y-intercept has to be when my x equals 0. But I literally have a situation when my x equals 0. That's 0, 0. So I should graph 0, 0, and 4, negative 4 comma 0. If you notice, it's 2 away from the axis of symmetry. That should always work like that. That's a good way to check your work. Your y-intercept is 0, 0, which means the mirror is also 2 away. So just connect your dots. All right, your domain is all real numbers. Your range, y is less than or equal to, because it's facing down. So y is less than or equal to 4. All right, or these ones. Write an equation in parabola form of this thing, of vertex form. I know the vertex is 4 comma 12, so I know so actually, let me say this first. When I write in vertex form, I need the a value, the h value, and the k value as in the final part. The x and y will say x and y in the final answer. Okay, a vertex of 4 comma 12 exists. So I know h is 4 and k is 12. Through some point, 6 comma 4, which means I have an x value of 6 and a y value of 4. Notice this is not h and k. So I'm going to plug in everything I see that I can. So y is 4 equals a, which I don't know, so I'm going to leave as a. X, which is 6, minus h, which happens to be 4 squared, plus k, which in this case is 12. 6 minus 4 is 2. 2 squared is 4. So 4 equals 4a plus 12. Minus 12 on both sides, negative 8 equals 4a. Divided by 4 on both sides, negative 2 equals a. Remember, your final answer is not negative 2 equals a, it's the actual formula. So y equals negative 2, x minus, we know what h is, 4, squared, plus 12. All right. Number 5. It has a vertex of negative 1 comma 10, so that's going to be h and k, and a y-intercept of 3. Since it's a y-intercept of 3, I know that means it's at 0 comma 3, so that gives me a point, x and y. So same process as before, we're just plugging in stuff. 10 equals, I'm sorry, I messed up. 3 y value equals a, which I don't know, parenthesis x, which is 0, minus h, which is going to be plus 1 squared, plus k, which is plus 10. So 3 equals 0 plus 1 is 1, 1 squared is 1, a plus 10, minus 10 on both sides, negative 7 equals a. So our final answer, y equals negative 7, parenthesis x plus 1 squared, plus 10. All right, next one. Write an equation with each quadratic and integral coefficients. So, if I know the roots are negative 3 and 2 over 5, I know right before this answer, it must have looked like x plus 3 equals 0. Because if I did that, I would do minus 3, I get x equals negative 3. So because of that, I know right before, it should have looked like x plus 3. And for this one, it's 5 over 2. So how did it look like 5 over 2? Well, it must have been x plus 2 over 5. But I want integral. If you don't know what the word integral means, that's a whole number that's either positive or negative or 0. So because I want these to be whole numbers, I'm going to times both of these by 5, which basically means I move the 5 to the front and rewrite this instead of x plus 2 over 5. I write it as 5x plus 2. Basically, I take the denominator and put it in front of the x. So now I'm going to FOIL to get my equation. So it's going to be 5x squared plus 2x plus 15x plus 6. Combine like terms. 5x squared plus 17x plus 6. All right, number 7, it has the roots of this stuff. Because it has the roots of this stuff, I'm going to have to rewrite it as x minus 4 plus 2y and x minus 4 minus 2y. We still subtract here, or do the opposite symbol. So in this case, it was minus, so it becomes plus. All right, because of that, I'm going to have to do a crazy 3x3 foiling. So x, I guess I'll do it first. I'll do a color coded. So the first thing, x squared minus 4x minus 2ix. Minus 4x minus, or I should say plus 8i. Wait, I'm missing something. Negative 4 times x. Oh, I did it. Negative 4 times negative 4 is plus 16. Then negative 4 times negative 2i is plus 8i. And then this one. Plus 2ix minus 8i minus 4i squared. Now, if you do this correctly, you'll notice a lot of the things cross out. So in this case, this and this cross out. So negative 2ix, positive 2ix, positive I, negative I. Negative 4i squared I could rewrite as plus 4 because the I squared is negative 1. Yep. And then you just combine like terms. X squared minus 8x plus 20. Yeah, that's it. If you do this correctly when you distribute the i's, there should be no i's left over. It should just be normal numbers. All right, in this case, I'm going to have to do this roots. When I do these roots, there's a 3 on the bottom, so that goes into the front. A lot of people forgot that part. So 3x minus 2 plus root 6, and 3x minus 2 minus root 6. Notice how I only changed the front. That's the easier way to do it. You're technically supposed to distribute, but you'll get the same thing. Again, this is going to be a super foiling thing. If you do it correctly, you should have no roots at the end. So negative 6x, I'm sorry, ahead of myself. 9x squared minus 6x minus 3x root 6 minus 6x plus 4 minus, or I guess it'll be plus 2 root 6 plus 3x root 6 minus 2 root 6 minus root 36, which is just normal 6. Cross out what we can, which I should be the roots pretty much. So negative 3x root 6, positive 3x root 6, 2 root 6, negative 2 root 6. Yep. So we get 9x squared minus 12x minus 2. All right. Next one. Let me see. How much we got? All right, let's just keep going. Next one. Variation and circles. Variation. This is the one right after Passover, if you don't remember. So variation, there are two main variations. There's directly. Directly is x over y equals k. I always said directly is division. There's also inverse. Inverse is x times y equals k. If I ever say jointly, that means together they are directly to each other. So we'll see that when we get there. All right. So for number one, if x varies directly with y, when x is 10, y is 15, find the constant. The constant is just k. Why did we use the letter k? I still don't know. So x is directly with y. So x over y equals k. But in this case, I actually know what x is. X is 10, and I know y is 15. So I can reduce that to 2 over 3. So 2 over 3 equals k. All right, now that I know it's k, I use it for the next question. Find y when x is 120. So 120 over y equals 2 over 3. You do some math, you're going to get 180. So y equals 180 by cross multiplication. Or you could see the pattern or whatever. I don't care how you figure it out. But it is going to be 180 in that case. 120 times 3 divided by 2, however you want to do it. All right, g varies inversely with h squared. So g varies inversely. So g times h squared equals k. And when g is 10, h is 6. So when g is 10, h is 6. So 6 squared. So that's going to be 36 times 6, 360. 360 equals k. Again, we use it for the next question. Find g when h is 15. So it's going to be g times 15 squared equals 360. 225. G equals 360. I'm just going to pull out the calculator. What's going to happen is 360 divided by this calculator. 360 divided by 225. This is going to be 1.6. So G equals 1.6 or 8 over 5. I don't know which way I will write it on the multiple choice. One or the other. Probably 8 over 5 because that's more doable without a calculator, but who knows. Either way, we keep going. If R varies jointly with Q and P squared. So jointly is the same as directly, basically. It's just multiple. So R varies jointly, or you can read it as directly with P. I'm sorry, directly with Q and P squared. So they're both a direct type. So jointly is kind of like direct. All right, solve when R is 80, P is 5, so 5 squared, and Q is 4. So 80 over 100, so that's going to be 4 over 5 equals K. 25 times 4 is 100, 4 over 5. All right, find Q when R is 200 and P is 4. So that's going to be 4 squared. That's going to be 16Q equals my fraction 4 over 5. That's going to be 250. Well, actually, let's just do the math long ways. So I'm going to cross multiply. So 5 times 200 is going to be 1,000 equals 4 times 16, 64Q. I'm going to divide 64Q on both sides, or 64, I should say, on both sides. Can I just type in here? Yeah, 1,000 divided by 64. 15.625. Actually, I want to see it as a calculator. Or as a fraction. Math frac. 125 over 8. Probably I would write it as 125 over 8 as a multiple choice. Again, make sure you have a calculator for the test. Alright, next one. Alright, water pressure varies directly proportional to how deep the water diver goes. So when Ari went 22 meters, he fell to 232, I think, kilograms per. I don't remember what this symbol means. It's how much pressure you get. Uh, that's how much pressure he feels when he goes 22 meters. What's the pressure if Aviva only goes 15 meters? Now, in this case, it's proportional. So you should just identify your variables. So x and y equals x and y. I think I called it 1, 1, 2, 2. But it's the same. You're just setting a proportion up. So since it's directly, it's a fraction. So xy over xy. So when RE is 22 meters, it's 232 equals Aviva is going to go 15 meters, which means I don't know what this is, so I'm just going to leave it as y. Because I'm going to leave it as y, I'm going to cross multiply. So I'm just going to take my calculator. 232. I'm going to times that to 15. And then eventually I'm going to divide by 22. So 158.1. 158.1 about. In the question in the multiple choice, I might say about what pressure it is. So then the multiple choice being 151.8 makes sense because it's a rounding. I guess I would round it properly. So 151, 158.2. Yeah. Okay. All right. How fast is a house painted is inversely proportional how many workers there are, because it's proportional, or inversely proportional. It's going to be x times y equals x times y. So Yedidi hires 8 workers, and it took 95 minutes. How long would it take if Manyan hires 6 workers, and I don't know how many minutes that's going to take. So again, I'm just going to use my calculator. 8 times 95. And then I'm going to divide it by the 6 workers. That'd be 126.6 or 126.7. So 126.7. If you ever want to think about it, always think of it logically. If Manyan has less workers, that means that it should take longer. If it's directly, if Aviva's going less deep than Ari, then it should be less pressure. You always could think of it logically. All right, this is a midpoint. Define the midpoint. That is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. That's the midpoint formula. So remember x1, y1. This is the x and y of group 1. x2, y2. This is the x and y of group 2. So 9 plus 6 over 2, comma, 3 minus 1 over 2. 15 over 2 is 7.5. 2 minus 2 over 2 is 1. So the midpoint is 7.5 over 1. The distance, the formula for that one, is the square root of x2 minus x1 squared plus y2 minus y1 squared. Reminder, you don't really care which one you call group 1, group 2. It does not matter as long as you're consistent. So in this case, it's going to be x2, which is 6 minus 9 squared, plus negative 1 minus 3 squared. So in this case, 6 minus 9 is 3 squared, plus negative 1 minus 3 is negative 4 squared. So this is 9 plus 16. So the square root of 25, which is just 5. All right. And this one, if you I kind of remember how people mess this up. This is my midpoint, and this is my end point. So in this situation, I know the midpoint is 7, 3. So I know it should be x1 plus x2 divided by 2 should give me 7. Since I know one of my endpoints is 10, I can replace one of these x's with 10. And then from there, I should just do algebra. Times 2 on both sides. 10 plus x equals 14. Minus 10 on both sides. X equals 4. And then over here, same concept. I know this should be my answer. So 9 plus y over 2 equals 3. Times 2 on both sides. 9 plus y equals 6, minus 9 on both sides, y equals -3. So your other point is 4 comma -3. Yes, there's I would say a caveman when you do it, but make sure you read it correctly. If you know, you know. Okay, find the center of the radius and then graph the following circle. All right, the formula for a circle was x minus h squared plus y minus k squared equals r squared. So in this case, what I'm going to do is take this and figure it out. X is not adding or subtracting anything, which means in this case, h equals 0. Y, it's y minus k squared, so you got to flip the sign. So k is 2. So my center is 0, comma 2. My radius is r squared. So in this case, it's the square root of 9. So my radius is 3. So, because it's 0, comma 2, I start at 0, go up 2. Now, because my radius is 3, I go 3 to the right, 3 to the left, 3 up, and 3 down. And then I just make my circle based off that. Here is the tough one because I have to actually complete the square. So let's first start this off by rewriting it with all the x's together, all the y's together, and all the normal numbers on the other side. So x squared minus 4x, leave a little gap on purpose. Y squared plus 2y, leave a little gap on purpose, equals positive 4 because I'm going to do plus 4 on both sides. So the first thing I do is move all my x's together, all my y's together, and move them by myself. Now, I need the perfect C for x, so I call that CX. Because I'm fair, I'm going to do it to the other side. And I need the perfect C for y, I call that CY. So I'm going to call this over here CY. Now to find the perfect value, remember, it's b over 2 squared. So -4 over 2 squared is 2 squared, which is 4. So this cx is 4. This cx is 4. Over here, I need the perfect y value. So the perfect y value, I'm going to cut it in half. 2 divided by 2 is 1. 1 squared is 1. So I'm going to put a 1 here. I'm going to put a 1 here. Now, this part over here, what multiplies to 4 and adds to -2? That's x minus 2 squared. This part over here, what multiplies to 1 that adds to 2? That's going to be x plus 1 squared. And then combine like terms here. 4 plus 4 plus 4 equals 9. Now that I look at it like that, I can just tell me what my center is. Remember, this is flipped, so h is 2, k is -1, and my radius is 3, which I could have wrote here. So 2 comma -1, 3, 2 right, 1 down. And then the radius being 3, so 3 up, 3 down, 3 left, 3 right, make a circle. All right, give an equation with this following scenario. The center is 4, comma 2, and the radius is 12. Since this is my h, this is my k. My radius is 12, so that means my r is 12. Because that means when I plug in the formula, it's going to be x minus 4 squared plus y minus 2 squared equals 12 squared, so 144. Because it's a normal number, you actually square it out. All right, next part. Rewrite, what is this one? Oh, this part, yeah. Okay, so when you have a fractional exponent, because you have a fractional exponent, I can rewrite it. The denominator goes inside the root, and the numerator goes outside the root. So 4 fruit of x to the 7th power. Now, it does not matter if it looks like this, or if you put the root on the power on the outside. These are both equivalent. Next one, over here, we're going to rewrite in exponential form. So, because this is a square root, that's a visible 2. So I'm going to rewrite it as x 10 over 2. Because it's 10 divided by 2, you should simplify. So x to the 5. Over here, I just want to rewrite in exponential form. So it's going to be x 4 over 3, y 7 over 3. Because remember, 3 is the denominator. Number 4, to simplify. Now, very seriously, I don't think you had calculators on this test when you took it. So you could just use the calculator on your tests. So 125 to the power of 2 divided by 3. That gives me 25. Yes, you can use your calculator. Let me show you how to do it the long way though. So 125, I'm going to rewrite it as the cube root of 125 to the second power. So cube root of 125, 555, so it's 5 squared, which ends up being 25. Okay, this case, when you have 8 divided by 8, they're the same base, so I could actually mix the exponents. To mix the exponents, I'm going to have to rewrite it as 5 over 4 minus 11 over 12. In order to clean this up, I'm going to have to change 5 over 4 into a like fraction. So this needs a 3. So 3 over 3. So I'm going to rewrite it as 15 over 12 minus 11 over 12. I'm sorry. Remember, when you divide exponents, you subtracting. So 12 minus 11 is 4. 4 over 12 reduces to 1 over 3. So this whole thing is 8 to the 1/3. But the 8 to the 1/3 is the cube root of 8. So that's 2. If it was a multiple choice, the final answer would be 2. Over here, now this is a funny one because this threw off a lot of people. There's 2 ways to tackle this. First off, because the exponents are the same, I could just multiply the normal numbers and get 8 2 over 3. Then the cube root of 8 to the second power. The cube root of 8 is 2. 2 to the second power is 4. That's one way to do it. Or I could rewrite the 4 as a matching root. So 2 over 2 over 3 times 2 to the second power 2 over 3, which would become 2 to the, this is the 4 over 3. So 2 thirds plus 4 thirds is 6 thirds, which is 2 to the second power, which is 4. There are multiple roots to it, but again, you could plug it into your calculator. All right. Again, if it's normal numbers, you can plug it in the calculator. If it's variables, you're not really going to be able to. All right, in this case, when we have an exponent, we multiply. So it's 3 over 2 times 4 over 3. Cross out the 3's. This reduces to 2 over 1. So 6 to the second power equals 36. All right, because they're both base 2, I could cross them out. And it's going to be x plus 2 equals 5x minus 2. Solve a little bit of math. 4. So it's just going to be x equals 1 after you do the algebra. Minus x plus 2, yeah. Over here, before I can set this across it out, I have to make these the same. So I'm going to change 1 over 5 to 5 to the negative 1 power. 3x minus 2. And I'm going to change 25 to 5 to the second power. 2x minus 3. So distribute that. 5 negative 3x plus 2 equals distribute the 2. 5 4x minus 6. Cross out the 5's. Negative 3x plus 2 equals 4x minus 6. Do a little bit of algebra. X equals plus 3, that'll be 7, plus 2 is 8, 8 over 7. All right, graphing exponential functions. As a reminder, you could take your calculator, click y equal, and it'll let you see the graph. So you can see that you're doing it the general way, but to find the specifics, you should do the actual specifics. All right. Over here, we have 3x plus 2 minus 5. So the y-intercept is when x equals 0. That's always true no matter what equation you're doing, quadratic, linear, cubic, exponential, doesn't matter. So I'm going to do 3 to the 0 plus 2 minus 5. So it's 3 to the second power minus 5. 9 minus 5, 4. So my y-intercept is 0, comma 4. My asymptote is just this value over here. So y equals negative 5. So what does that mean? That means I have like a dotted line along negative 5. And I have a y-intercept at 0, comma 4. Now you should identify if it's a growth or decay. Because this number is a whole number 3, or I should say bigger than 1. It's a growth. So how I draw it is how it's going to look basically. It's going to be a little bit closer to the line, and then reaches up to the dot, and then shoots up. Now, just to show you in the calculator, you can do the same thing. I'm going to click y equals. I'm going to type it in. So 3 to the power of x plus 2, go to the right, minus 5. Graph that. You can see this is like negative 5, kind of flat. Then it gets closer, hits 0, comma 4, and then shoots up. All right, next one. We have these functions, f, g, and h. I got to tell you what f, g, and h is so you can do it. But using these functions, we're going to figure out some stuff. So when I say f of negative 1, some people forgot this means inverse. So here's the process of inversing. First thing I'm going to do is rewrite f of x as y. So y equals 3x minus 5. Then I'm going to swap x and y. So x equals 3y minus 5. And then my next job is to get y by itself. So plus 5 plus 5. Now you're just doing basic algebra. X plus 5 equals 3y. Divided by 3 on both sides. X plus 5 over 3 equals y. And then you just change it back. So x plus 5 over 3 equals f of negative 1 x. All right. This one, 12, is the inverse of this. Now, for when you inverse this one, you're going to get y equals x squared minus 1. X equals y squared minus 1 plus 1 on both sides. X plus 1 equals y squared. Square root on both sides. The square root plus or minus the square root of x plus 1 equals y. Now, the problem with this is that you have a plus or minus. A plus or minus cannot exist for a function. So when I rewrite this as g negative 1 of x, that cannot be possible. And because that cannot be possible, this is a no inverse. A no inverse typically happens when you have a square or even power, so square, fourth power, sixth power, eighth power, or an absolute value. Don't worry about the absolute value thing. All right, when I say h of 3, that means I'm going to take the function here of 5x minus 1 over 2. And since it has 3 here, I'm literally going to replace it with 3. So 5 times 3 minus 1 over 2. So 15 minus 1 over 2, 14, 7. Functions, you just plug it in. So in this scenario, I'm just going to zoom out so I can see the functions at once. In this scenario, we got f of 2 inside g. So the first thing I'm going to do is figure out what f of 2 is. So 3 times 2 minus 5. That's 6 minus 5. That's 1. So now I'm going to rewrite this as g of 1 because I just found out what f of 2 is. This is f of 2. So I plugged into the f. Now I'm going to take the 1 and plug it into g. So it's going to be 1 squared minus 1, which ends up being 0. So the final answer for that one is 0. Now it says g of x. I know what g of x is. Literally, you tell me what g of x is. So I'm going to rewrite it as f of x squared minus 1. Because I wrote it as x squared minus 1, I'm going to plug it into my x, whatever's in my parentheses. In this case, x squared minus 1. So it's going to be rewritten as 3 x squared minus 1 minus 5. Let me distribute the 3 to clean this up. 3x squared minus 3 minus 5. 3x squared minus 8. Okay, next one. I got to do g minus 4 first. So negative 4 squared is 16. 16 minus 1 is 15. So h equals h of 15. I'm going to take 15, plug it in. 5 times 15 is 75. 75 minus 1 is 74. 74 divided by 2 is 37. Yeah. All right. Wait, 5 times 15? Yeah, that's 75. Okay. All right, now we're on logs. Logs. Now, I know it says here calculator section, non-calculator section. Lucky for you guys, they're all, the whole test is calculator section, so you could use the calculator to do some of the easier parts. First off, we have log base 3 to 100. Remember, I don't have log base 3 on my calculator. I only have normal log, and I only have ln. So because I don't have that, what I'm going to do is have to rewrite it as log 100 over log 3. So I just take my calculator and type log 100 divided by log 3. 4.19. Over here, again, same problem. Log 12 divided by log 4. Log 12 divided by log 4. 1.79. Over here, I need to get x by itself. So when I move over, it's going to be x equals log base 5, 42. When you move over a base of an exponent, it becomes the base of a log. So x equals log base 5, 42. Again, slap that into your calculator properly. So log 42 divided by log 5. 2.32. All right. Hunter invests 7K into a bank with 7% interest. Calculate each month. If he keeps it there for 6 years, how much will he have at the end? All right. So 7K is my principal amount. That's how much he's putting in. My rate is 7%. But remember, you have to change it to decimal. So that's 0.07. He's going to keep it there for 6 years. So that's the time. Now, it calculates every month. Because it calculates every month, that makes my n. So my n is 12. So the main formula is A equals P times 1 plus R over N to the power of NT. So we got all our symbols. We just got to plug it in. So literally 7,000 times 1 plus 0.07 divided by 6 to the power of 6 times 12. Oh, I'm sorry. I almost messed up. Divided by 12 because it should be N on the bottom. So 12. To the power of 6 times 12. Now we just take that calculator and do it. 7,000 times 1 plus 0.07 divided by 12 to the power of 6 times 12. If you want to write just 72, that's fine. I'm minimizing the errors I'm making. 10,640 and 74 cents. So 10, 640, and 0.74 cents. That's all I want to do. That's all I'm going to do. All right. In this one, we're seeing rabbits in the forest. He releases 200 rabbits. It takes 5 months to double the population. How long does it take to be 2,000? So for this one, did I put NF? I think I did. So the number, no, it can't be. Maybe it was N. So your final amount equals your initial amount, either n0 or ni. I forgot how I wrote it. Times, this is doubling. Because it's doubling, it's 2 to the power of t over d. D being how long it takes to double. So 200 is my initial, so n0, I guess. 5 months is going to be my um, doubling amount, so that's d. 2000 is going to be my final amount, so that's nf. So 2000 times, or equals, I'm sorry, equals my initial amount, 200, times 2 to the t over d. I don't know what t is, but I know d is 5. So I'm going to divide 200 on both sides. So 10 equals 2, t over 5. Um, you have to bring the 2 over. So it's, let me rewrite it. Log 210 equals t divided by 5. And then times it by 5. So 5 log base 2, 10 equals t. So in this case, we just type it in. 5. Now it's log base 2, so I got to rewrite it correctly. So 5 times log 10 divided by log 2. 16.6. So it'll take 16.6 months. Yeah. All right, next one. Invests in the bank for 5% interest continuously. If she invests for continuously. If she invests for $10,000, how long does it take to double? So people got thrown off because I said the word double. But double is describing the final amount. So I want to know how long it takes until she gets 20K. So you have to be able to read, I guess. Continuously tells me it's going to be E. 10,000 is my initial amount, so that's P. My rate is 5%, so 0.05. So in this case, it's 2,000 times 1, or equals, or I'm sorry, let me write the original formula. The standard formula for this is A equals P to the E to the power of RT, or PERT. This is for compound continuous. So in this case, it is 20K equals 10K times E to the RT, which is 0.05T. So in this case, I'm going to divide 10,000 on both sides. So 2 equals E, 0.05T. Now I got to move E to the other side. The base of E is ln, so it's ln2 equals 0.05T. Divide 0.05 on both sides. I just go to my calculator. Luckily, I have an ln button, so I don't have to do any change of base. So ln2 divided by 0.05 is 13.86, so 13.9 years. Was it? Yeah, years. All right, this section. This section you don't need a calculator, but again, you have a calculator on the test, so you could use it if you really need it. So over here, when I rewrite this exponential form, I got to bring the 5 to the other side. So 125 equals 5 to the third power. When I want to change this to log form, I'm going to take the 9 and bring it to the other side. So it's going to be negative 2 equals log base 9, 1 over 81. Over here, because this is 5 and log 5, I could cancel it out. It's 14. Over here, it's log base 2, 4 to the 5th power. They don't match. So I'm going to rewrite 4 to the 5th power as 2 to the 2nd power to the 5th power, which is going to be 2 to the 10th power. Now it's log base 2, 2 to the 10th power, which I can cross out and just left with 10. Over here, log 6 of the 1. Just a reminder, if you set it equal to x, I could take the 6 and bring it to the other side. 1 equals 6 to the x power. So you could ask yourself, 6 to what power gives me 1? Well, anything to the 0 power equals 1. So this equals 0. This one, L and E are opposites, so that's just 4. Over here, when I expand each log, multiplication means addition, and exponents mean multiplication. So it's going to be log x plus 3 log y. Over here, ln is going to be square roots is, remember, to the half power. So I'm going to rewrite this as x to the half power over y to the third 1/3 power. It's division, so it's subtraction. So it's going to be ln, 1/2 in the front, ln x minus 1/3 ln y. Over here, condense. So when I condense this, I'm going to combine this. So log plus is multiplication, so 20 times 5 divided by minus is a division, so divided by 4, which will be log 100 over 4, or 25. So log 25. If it's a multiple choice question, it will look like log 25. Over here, because I have the 3, that goes to the power. Because I have the 2, that goes to the power. So it's log 2 to the third power minus log 3 to the second power, which I could rewrite as log 2 to the third power divided by 3 to the second power, which, because they're actual numbers, I will do the math, log 8 over 9. Over here, these numbers should go to the exponents. Plus means multiplication, subtraction means division. So it's going to be ln x to the third, y to the second, over z to the 4. All right, leaves in terms of ln. So what we're going to do is first I'm going to divide both sides by 3. So e to the x minus 1 equals 7. Then I'm going to move the e to the other side. So x minus 1 equals ln 7. Then plus 1 on both sides. Remember, this ln is in here, so it cannot be affected. So it's ln 7 plus 1. The 7 cannot be affected by the plus 1. If it was a multiple choice answer, would I give you a fake answer as ln 8? Absolutely, so don't get tricked. Over here, leave in terms of e, so I'm going to divide both sides by 3. So I get ln 2x equals 10. Now I got to move ln to the other side. It's the base of a log, so the base of a log becomes the base of an exponent. So 2x equals e to the 10 power. Then divided by 2, then divided by 2. X equals e to the 10th power divided by 2. Over here, because they're both logs, I could cross them out. So it's 4x plus 1 equals 6x minus 2. So that's going to be x equals 3 over 2. Wait, 2, 3, yeah, 3 over 2. Over here, because this is plus, I first have to combine these before I cancel out. So when I combine them, it's going to be 12x. So ln 12x equals ln 10x plus 10. Now I can cross out the ln's. So 12x equals 10x plus 10. Subtract 10x on both sides. 2x, and then minus divided by 2, x equals 5. Over here, because they're both logs, I have to multiply. So I'm going to distribute. So I'm going to get x squared plus 2x log base 2 equals 3. Now I can't just set it equal to 3. I got to take the 2 and bring it over to the other side. Will I make a fake answer as if you set it equal to 3? Of course. But don't get fooled. So x squared plus 2x equals 2 to the third power, which is actually 8. So it's going to be x squared plus 2x minus 8 equals 0. What multiplies to negative 8? It adds a 2. X plus 4, x minus 2. Now, each answer, negative 4 and positive 2. Now, will I put an option where it's negative 4 and positive 2 as a choice? Yes, but that's not the correct option. Negative 4 cannot be an answer because you cannot have a negative inside your log as a result. So if I plug in negative 4 here, it will cause the whole log to be negative. So negative 4 cannot happen. So the only correct answer is actually 2. All right, we're almost there. I think It says to have an hour 30 I've been doing this, so we're almost finished. All right, over here, we're going to do sequence of series. So, to figure out the sequence, what you're going to do is arithmetic, geometric, or neither. So, in this case, I'm just looking. It looks like it's getting divided by 2. How can I make sure for fact? I put new divided by old, or future divided by past, or forward divided by behind. I don't care how you think of it. So, 5 over 10 is 1 half. 5 over 2.5, I'm sorry, the other way around. 2.5 divided by 5 is 1 half. And if I do 1.25 divided by 2.5, it's 1 half. Since I can see that's consistently true, that's going to be geometric. It's new divided by old to check for geometric, and for arithmetic, it's new minus old. Here, you can see it's plus 4, plus 4, plus 4, arithmetic. Over here, technically the pattern is plus 1, and then plus 2, and then plus 3, and then plus 4. But that's not an arithmetic sequence. The arithmetic sequence has to be consistent. So in this case, it's neither. All right, for this one, the following arithmetic sequence give the rule and give the as term. So first off, in order to find the arithmetic sequence, I need to know the arithmetic formula. That's Tn equals T1 plus D n minus 1. So I need T1 and D. So T1 is the first term. Looking for me, that's pretty obvious. That's 11. And D, you could probably figure out the pattern, is minus 6. So D is minus 6, n minus 1, Tn. Because of that, I'm going to plug in 54. So 11 minus 6 times 54 minus 1. So in this case, I'm just going to slap that in the calculator. 11 minus 6 times 53, just to save me time, is negative 307. Over here, A3 is 20 and D is 12. In this case, I need to figure out what A1 is. But I do have A3 is 20, so I know N is 3 and A3 is 20. So I could use that to my advantage. Or Tn, I should be saying T, my fault. So it should be 20 equals T1, which I don't know, plus 12 times 3 minus 1. So this is going to be 24. Subtract 24 on both sides. Negative 4 equals T1. Now I need the formula. The formula is Tn equals negative 4 plus 12 n minus 1. So now we do the math. Negative 4 plus 12 times 15 minus 1. Again, just slap that thing in the calculator. Negative 4 plus 12 times 14, pretty much, 164. All right, to find the arithmetic mean, you just add them and divide by 2. So 12 plus 50 divided by 2. 62 divided by 2, 31. All right, geometric sequence. The geometric sequence is this formula. Tn equals T1 times R n minus 1. Because of that, I'm just going to rewrite the formula. So I know T1's 1,000. So 1,000 times 1 half to the n minus 1. Because I'm going to plug in 6, 1,000 times 1 half to the 6 minus 1. So 1,000 times 0.5 to the power of 5 is 31.25. Sorry, I'm a little explaining, but I've been doing this for an hour 40. So next one, for this, it's you got to figure out the pattern. So T1 is 2 and R is 3. So I'm timing 3 each time. So the formula is Tn equals 2 times 3 n minus 1. So 2 times 3, 10 minus 1. So 2 times 3 to the 9th power. Three nine three six six. When you find the geometric mean of something, you do 12 times 75 square rooted. So 12 times 75. I need the calculator. Equals 900. The square root of 900 is 30. Okay. Rewrite it in terms of sigma notation. So in this case, first I need to figure out what my T1 is. My T1 is 9. I need my D, which is D is 4. So when I rewrite it as sigma notation, I need the n equals 1. Always is the bottom. I don't know what my final n is. I know it ends at 81, but I need to figure that out. But I know my formula is going to be 9 plus 4 n minus 1. Now to figure out this, what I'm going to do is just set it to equal to 81. You could caveman it, but just set it equal to 81. 9 plus 4 n minus 1. And then I'm just going to use a calculator. 72 divided by 4 is 18. And then plus 1, 19. So it's 19. So n equals 19. So I put a 19 on top for this one. Over here, it's going on forever, so it's infinite. So luckily for me, the top is kind of easy. So this is infinite. N equals 1. It starts at 5, so T1's 5. My pattern is negative 2, so negative 2 to the n minus 1. Alright, this one over here, we need to find the sum of this. This is the arithmetic. If you don't know why, it's because it's an opponent. Yes, this should be the letter n, not x. My bad on that. So because of that, it's going to be n. So it's going to be this formula. S of n equals n times t1 plus tn over 2. So you got to figure out what n is. That's 22. You got to figure out what T1 is. So you plug in 1. So 3 times 1 plus 2 equals 5. And you got to figure out what Tn is. So I got to plug in through 22. So 22 plus 2 is 66 plus 2, 68. So it's going to be 22 times 5 plus 68 divided by 2. Again, I'm just going to go to my calculator. 22 times, it's 5 plus 68 is 73, divided by 2, 803. Over here, we got to use this formula because it's geometric, so Sn equals T1 times 1 minus R to the n power over 1 minus R. So you got to figure out T1 is 3. You could caveman it, or you know the first term is going to be 3. And then the second thing is going to be inside the parentheses your R, which is 2. So because of that, it's going to be 3 times 1 minus R, which is 2, to the power of my exponent. Oh, I'm sorry, I should point that out, is 5. Click right if you don't want to be in the exponent anymore. Divided by 1 minus 2. Enter, enter. 93. Over here, I would love to do this, but the problem is this is 7 over 6. When I do infinites, it has to be, the R has to be in between 1 and negative 1. The absolute value 1 and negative 1. So because of that, negative 7 over 6 is too big. So 7 to 6, this is divergent. Over here, though, I can make the pattern. If I remember, I made a mistake. This should be technically 40, and this should be 80. So because I do it like that, I got to figure out what my pattern is, where n equals 1. This goes to infinity. And then in this case, it is, we first change it from 90 to 60. So 90 is my first term, and the rate is 2 over 3. I remember I messed it up because I turned it into 1 over 3 along the way, which is my fault. Or I messed up. It should be just 40, and then this should be 80. Okay, so that's true. So then I can use the formula for an infinite geometric sequence because my R is in between 1 and negative 1. So it's going to be T1 over R minus 1, or 1 minus R. So in this case, it's going to be 90 over 1 minus 2 over 3, which is 90 over 1 over 3, which is going to be 270. All right. Hope that helps. Use any old homeworks, any old tests, any old whatevers to help you study for this. Don't overstudy for it. You don't really need to overstudy for it. Just get a general feeling. Remember that multiple choice will help you guide you and make it a little bit easier along the way. Good luck. Have a wonderful day.